Okay, so for this video, we're going to talk about the limited reagent. Before we move on, one of the questions, okay, we're going to show you a general steps for calculating the limited reagent. So first of all, you'll find that, okay, we'll have to write a balance equation. Say, for example, you have things like this. Okay, then you write down the data. For example, this one you have A, B, okay, so this one is maybe in terms of gram, okay? So after you got these two, okay, then you're going to do the third part. The third part, you're going to find out the number of mole of A and B, okay? So using this A mass, okay, and then you're going to find it the number of mole, okay, by divided by the molar mass. So for example, if this one, okay, you convert it into X mole, while this one to be Z mole. Okay, so by doing this, okay, we can then, okay, comparing or which one is limited, which one is excess. So for example, okay, we write a statement like this way. So you tell the others, okay, to react with, okay, for example, if we have like X mole of A to react with X mole of A, okay, we need Y mole of B. This one is ideal amount, okay. What means by ideal amount, okay, to calculate this one, okay, we may need to using X divided by 2 times 3, okay, and then you come up with like X, Y mole. So this one, okay, will X divided by 2 times 3, so you will find out the ideal amount of B that required to react all the X mole. So therefore you use X divided by 2 times 3, then you find out a Y mole. This is the ideal amount of B that you want to have. Okay, and then afterward, okay, you compare this Y mole, okay, with Z mole. Z mole is the reality, the real amount, You see that, okay, while the ideal amount is more, or the real amount is more. If the real amount is more than Z, then this B, okay, will be in excess. But if you find that, okay, you need Y mole, but actually you just have Z mole only, okay, that means smaller, Z mole is less than Y, okay, then in that case, B will be limited, okay. After that, okay, what you need to do is using the limited agents, the limited reagent. For example, in this case, okay, let's say B, okay, will be the limited reagent. B is the limited reagent. I use this one to calculate the number of mole of C. Calculate the number of mole of C. Remember, you must use the limited reagent to do that. If B is the limited reagent, then you divide it by 3 and then times 1 will do. Okay, so let's move on some example. I've got 4 examples for you, okay, so you can have a look of it. So the first one, okay, so CU2, you can pause the video so have a look at the questions, try to do it out first, okay, and then we check it together. So this one, okay, we have a equation which is 2Cu2S plus 3O2. Then you have like 2Cu2O plus 2SO2, okay, given right there. Okay, and the question is saying that, okay, formed when 3 moles of Cu2S, okay, so you have 3 mole here, and then you got 5 moles of oxygen. So this question is simplified, okay, you didn't require you to calculate the number of moles of A and B, but the target that you're looking for, okay, it is the mass of Cu2O. So by doing this, okay, we can directly jump into the statement form, okay. So you can say to react with 3 mole of Cu2S, okay, we need, okay, so you got 3 mole here, right? So you will first divide it by 2, then times 3 to find out the ideal mole of O2. So you have like 3 divided by 2 and then times 3. So this one will be 4.5 mole. So we need 4.5 mole O2 to react. But now we have 5 mole O2. So you find that this one, okay, it is the actual amount, okay. So this one is the ideal amount. So in this case, ideal, we need 4.5, but we have 5 mole. So therefore, what we have is more than enough. Therefore, O2 is in excess. So if O2 is in excess, then Cu2S, this one will be limited. Okay, so now, okay, what we need to do is to move on to calculate this number of mole. So next, number of mole of Cu2 Cu2O. So it will then be 3 mole divided by 2 times 2, okay, divided by 2 times 2. And then you find out this one will be 3 mole. And then for the mass of Cu2O will then be 3 times 63.5 times 2 plus 16, okay? The answer for this one should be 429 gram. Okay, got it? So do remember, okay, you have to find out the limited one first, okay, and then based on the limited, this is the limited, then calculate the number of mole of the other product that you want to measure. Okay, so how can I know that this one is a limited reagent related questions? Or do pay attention, okay, for limited reagent questions, okay, normally you got two number of mole of two reactants, okay, you got one reactants, you got two reactants, okay, you got two reactants with different number of mole, then you have to find out which one, okay, will be the limited reagent. Okay, next, okay, so this one, okay, is a more difficult one. Okay, you need to calculate the number of mole by yourself. So you have like CO2, you have H2. So the step 1, you write down the equation, balance equation. Step 2, okay, you can write down the data. You have like 6.6 gram, okay, you have 1.2 gram H2. So this is stage 1, step 2, okay, and then step 3AB, okay, you're going to find out the number of mole of CO2 and H2 correspondingly. So for CO2 would be 6.6 divided by 44. So this one will be 0.15 mole, while the other one will be H2. So you got 1.2 divided 1 times 2. So for this one will be 0.6 mole. Okay, so the statement to react with 0.15 mole CO2, we need, so you use 0.15 divided by 1 times 3 divided by 1 times 3. Okay, so you need around 0.45 mole H2. But now we have 0.6 mole. So what we have is more than the ideal one. Okay, so we have like 0.6 mole H2. Okay, more than ideal. So therefore, okay, H2 is in excess. So if this one is in excess, then we will know that, okay, we have to use the CO2 to calculate what we're looking for. We're looking for the mass, okay. So we're going to find out the methanol, okay, by doing this, okay. So next, okay, for the methanol, CH3OH will then be 0.15 divided by 1 times 1, so will be 0.15 mole as well. So the mass of CH3OH will then be 0.15 times 12 plus 4 plus 16. So the answer for this one will be 4.8 gram. Okay. Oh, next. Step 1, okay, you write down the equation first. Step 2, you write down the corresponding data. So you have 57.6 gram, you have 22 gram, okay, and then you're looking for the carbon dioxide form. Okay, step 3, okay, you're going to count the number of mole of each of the reactant. So this one will be 22 divided by 12 times 3 plus 8 times 1, okay. So for this one is around 0.5 mole. While the other one, you have like O2, so it will be 57.6 times, divided by 16 times 2. So this one is 1.8 mole, okay? And then step 4, okay, that will be the statement to react with 0.5 mole C3H8, we need, so it will be 0.5 divided by 1 times 5. So we need 2.5 mole O2. But we have 1.8 mole O2 only. So this one, you find out this one will be smaller than the ideal. If it's smaller than the ideal, then O2 is limited. As O2 is limited, I will use this one to calculate the CO2. Okay, so next, okay, number of mole of CO2 will then be 1.8 divided by 5 times 3. So this one will be 1.08 mole. And then for the mass of CO2 will then be 1.08 times 44. So the answer for this one is 47.52 gram. Okay, so the last one, okay, so the last one, again, write down the equation. Do remember you have to pause the video and do it on your own, okay, and then we check the step, okay, is it the same as what I am doing? So this one, okay, remember chemistry all the time, okay, we'll write something like this, okay, 452 gram of dioxide. Dioxide actually is referring to this oxide, okay, the oxide mentioned before, okay, so this is 452 gram, and then you have like 60 gram of carbon, and then you can find out the mass of tin. Tin, okay, the symbol is SN, okay, so step 3, okay, will be SnO2. So this one is 452 divided by, okay, you do the math, okay, it should be things like this, okay. So this one will equal to 3 mole. Will equals to 3 mole. While the other one, okay, like number of mole of C, so we have 60 over 12. So this one will be 5 mole. Okay, and then to react with 3 mole SnO2, we need 3 divided by 1 times 2. We need 6 mole carbon. But now we have 5 mole carbon only. So this one is less than ideal. So therefore, C is limited. Okay, and then using this time, then we use C to calculate Sn. Okay, so number of mole of Sn will then equals to, we'll use 5 mole, 5 divided by 2 times 1, so will be 2.5 mole. Okay, and then mass of Sn will then be 2.5 times 118.7, and then the answer will be 296.75 gram. Okay, so that's all for all the examples that I've done for you. Okay, so you can practice a few more times. So to end up, okay, the conclusions, okay, we'll have like write equations, jot down the data, remember where you have to go, okay, and then you find out the number of mole of A and B. Normally, if you require to consider limited reagent or not, okay, you will be given 2 sets of data, so you will be able to calculate the number of mole of A and B, okay, and then you use the statement like this way, okay. So you see that normally I will include a steps right there, like X divided by something, okay, and then you equals to Y. So it will be easy for the others to follow, okay, what you are doing at the time, okay. And then you have the real amount and ideal amount. You do the comparison between them, okay, to find out whether they are limited or in excess. At the end, okay, you use the limited reagent to find out the number of mole of C, and then you calculate the answers. Okay, so that's all for this video. Bye bye.